Hey, Grant. So I just wanted to get a fruit snack. I saw I only had 5. I had 6.
So, what's that have to do with me?
Well, you were at my house earlier. Did you steal one of my fruit snacks?
Okay, it was me. I'm sorry.
I just hit him so hard that he fell over. Now, if you think about it force-wise, you would think the force of my fist hitting his face would be a lot greater than the force of his face against my fist.
Wrong.
We headed over to our local Schroeder to ask other people what they thought of this perplexing problem.
Hello, we were with the Kroger worker, Christian Keene here. We're going to ask him a few questions about physics.
Alright, watch this demonstration here. We're gonna
You ready for this, Christian?
I'm ready.
Okay, so when these two cards hit, this card is clearly heavier than that card. Which one has more force against the other one when they meet?
This card.
It's incorrect, Christian.
We're here with Shopper Luke, and we're going to interview him about physics. Alright. So just watch this demonstration here.
Here we go. Ready? So, when these two cards meet, at the point they meet, which one has more force upon the other?
I feel like this one has more force because after it was hit, this cart was pushed further back.
Well, we are here with another Kroger customer, Mark, today, and we're going to ask him a few physics questions. So we're going to show you this demonstration here. So, when the two carts come in contact with each other, which cart, at the moment they meet, do you think has more force on the other cart?
This cart has more force because it's got some weight in it and it's being pushed.
So the common misconception showed by all 3 people we interviewed is that the cart that is being pushed and that has the more mass has more force on the other cart.
This is incorrect because Newton's third law states that every action has to have an equal and opposite reaction. If one card had more force than the other, then that rule would be violated. So, as a condition,
So why do you
looks
think that?
like
This one is
heavier.
heavier?
Yeah,
Has more stuff in it?
Yeah. Well, actually, at the time they meet, they have the same amount of force against each other. It looks like this is less force because it moves, but that's because the mass is so much less, so it's affected more by the force.
Okay, makes sense. Yeah, I get it.
Thank you.
Is that it? All right, thank you guys.
Yeah.
And I'll explain why that's not right. So this does fly further, and you would think that's because this applies more force, but actually they apply the same amount of force, and this one goes further because it's affected more by that force because it has a lower mass.
Okay.
Yep.
Makes sense?
Yeah.
Cool. That's it. But here, we're going to show it again, and I'll explain to you why that's not the case. Alright, so this card is pushed further, and this card definitely has more mass, but according to Newton's third law, for every action there's an equal and opposite reaction, and that's what's happening here. While this card is moved more, the same amount of force is being applied to each cart. It's just that this is affected more because it has less mass and no velocity. So,
Does that make sense?
The third law.
Yeah, the third one. Cool.
well, that trip to Schroeder really showed us that people don't care about Newton's third law.
Right. Every action has an equal and opposite reaction.
Like in this case, the force of the heavy cart on the light cart is equal to the force of the light cart on the heavy cart, just in opposite directions.
Exactly. An interactive force pair.
Like my fist with your face earlier when I socked you.
Sure. So we've learned 2 things today. One is that when 2 objects hit each other, they have equal and opposite forces. And secondly, don't steal Jaret's fruit snacks.
Don't do it, please.